So here's the quick introduction about Vijay. Vijay has over 14 years of professional experience with 5 years in architecture role, covering all aspects of software cycles. He is also the innovation lead in Severity for upcoming technologies such as AI, which includes chatbot, cognitive service, and machine learning for India. Vijay is also an enterprise architect for MS Stack, which includes Azure and Office 365 technologies. He's involved in solution estimation, RFP response for project across various industry verticals. So over to you, Vijay, to let us know more about how we could access the vehicle damage the ML way.
Thanks, Deepika. Hi, everyone. I hope everyone is able to hear me.
Yes, we are able to hear you.
Okay. So, today's topic is on the vehicle damage detection. Um, it's a white paper that me and my team had written. The way we could automate the solution for assessing the damage of a vehicle using deep learning. So I'll just go ahead and share my screen. Uh, I believe you should be able to see my screen right now.
Yeah.
Okay, so today's topic is about vehicle damage detection, a problem statement that we want to address using the machine learning, deep learning techniques. So as part of this, the first thing is about the problem statement that we want to address. So we do understand that in the current insurance industry, there is a problem to be able to identify the leakage that happens in claims, which is whether what is being charged by the customer, what is being charged as part of the replacement or the damage done to the vehicle, whether it is a fair assessment or not. So typically to address that, there is a need for a visual inspection by a person manually to be able to identify the vehicle damage that is done. And as part of that, this leads to a further problem that it leads to a delay in the claims processing. To the end consumer, this is one of the problem statements that we think needs to be addressed. So as part of the solution, the idea is to have an automated system to assess the damage of a car using a deep learning model. And after assessing the damage, there would be a cost estimation model which also gives the replacement cost or the cost for repairing the vehicle. So now what this leads to is a faster claims processing because we do away with the visual inspection. It'll all be done by click of a photograph on the mobile, and then the deep learning model comes into picture to be able to real-time assess the damage which is done to the vehicle. As you can see in the photograph below, it's able to determine that there is a damage on a portion of the car, and hence leads to a faster claims processing and eliminating a manual intervention, thereby providing a cost benefit. So this is the topic, and now we will walk through the details of how the solution would be implemented. Okay, so as a first step, since we're dealing with using machine learning models first I would like to take a small step back and try to understand what artificial intelligence is. So essentially, it's a way to make a software think intelligently. That is a brief summary about what artificial intelligence is. And there are various categories as part of artificial intelligence. As you can see on the right hand side, there are various peers, categories where artificial intelligence comes into picture. You do have robotics, you have speech, sensory recognition, natural language processing, and machine learning is just one part of it, as against the popular perception that machine learning and artificial intelligence both are synonymous words, which is not the case. Machine learning is in fact a part of artificial intelligence, and deep learning, which is again a subset of machine learning, and then you have other areas, which is image analysis and so on. So this, in a brief nutshell, is the various areas that artificial intelligence covers. Moving on, just to reiterate, as you can see, the artificial intelligence is the bigger umbrella, which basically helps machines to act like humans, replicating their behavior. And machine learning is a subset of artificial intelligence. Right? It helps in basically learning, creating programs that learn from the data so that it can then perform activities without being explicitly programmed. And the deep learning is again another subset of machine learning, right, which is basically used and created using the neurons, the way the neurons of the nervous system behave, and it's basically used to identify more complex problems. We'll see that as we move further. So this is an abstract of the problem statement, and what we're trying to achieve here. We're trying to replace the traditional methods of a vehicle damage inspection, detection for the insurance, especially with respect to the auto industry, and trying to replace it with a machine learning based solution using deep learning models, and to be able to determine where the vehicle damage is, and also the severity and the type, that is localizing where the damage has occurred. And it opens doors, taking a step ahead in terms of automating this kind of a problem statement and help in faster claim settlement. Okay, so I'll move now to the solution architecture, which is basically the overall how the overall architecture looks like. So as we discussed, what's currently happening is there is a claims leakage, which is the difference between what should be genuinely paid and what is actually being paid to the to the damage done, and hence there is a need for a visual inspection, which leads to a delay in the claims processing. And how we should be addressing this is we should eliminate this manual intervention, and we're going to replace it with an automated machine learning system. So what you see below is actually a deep learning model, which is basically using CNN, that is convolution neural networks, typically used for image processing, which helps in classifying the image severity in terms of its damage type, that's where the damage has occurred, and even the severity, whether it's a low, medium, or complex. Once it goes through that, the model then goes through another solution, which is a cost estimator. So based on the damage type and the severity and the make and model of the car, the cost estimator solution can help in providing an estimated cost for repair or replacement. So this in a nutshell is what the solution architecture looks like. Now, that was the architecture that you had seen. Now, what we're going to see here is how the solution would look like in a real-time implementation, right? So, as a first step, what happens is what you see on the left-hand side is that the customer would upload an image of the damaged vehicle on his mobile app or the web portal, right? Then what happens is a deep learning model comes into picture. It gets called using an interface, and it analyzes the uploaded image and then classifies it as the following types of damages, whether it's a dent, whether it's a shatter or a scratch or a smash, which we had seen in the previous slide, where the model is able to do that kind of classification. And as you can see below, this model is based on using convolution neural networks, which is a deep learning model typically used for image processing, which is built upon, or rather, the model is heavily enriched with a huge amount of vehicle images, data set that is built of various types of images, which are damaged, undamaged, which is all fed in into this model. So as the next step, which is the step 4 that you see on the diagram, the trained model analyzes the input images and then appropriately labels the damage, whether it's a smash or a scratch, and where the damage has occurred. Finally, as part of step 5, uh, the system generates a cost estimate that is to be paid by the insurance company. And this, in a nutshell, is the step of activities that would be performed by the customer when the damage occurs, that would replace the traditional method of vehicle damage assessment and detection. So just to reiterate, this is the typical steps, and this explains the steps 1 through 5, which I've already covered in my earlier slide. Now, coming to the details of the solution. So the primary two components within this AI-based solution is it consists of a deep learning model and the cost estimator, right? And the deep learning model is enriched with a huge amount of input data. So it's been fed in with a huge amount of images, right? And the images are typically labeled. Now, the images we've built or rather categorized is it with three types. One, where we have images without cars. So the model basically tries to identify in the first step whether the image that is being uploaded has a car or not, right? So that's why we feed the model first with different types of images with and without cars. As a second step, we train the model to identify whether the vehicle is damaged or not. So we build a huge amount of data set of different types of cars which are damaged, which have a scratch, not a scratch, and those which do not have a scratch. So that's another step in the process where we try to identify whether the vehicle is damaged or not. And then finally, the next step is where we try to identify, the damage severity and the damage type. Type would be whether it's a scratch or a dent, and the severity would be whether it is a high, medium, or low. Okay, so this is the first step of being able to build this data set. Now, typically, there are various ways to do this. You could use ImageNet. We've used ImageNet. We've used. You could even scrap the internet, Google, using Python scripts to be able to get this data. And then one approach is you either label this data manually, or that's again a time-consuming process, given that the model needs to learn from huge amounts of data sets, right? So we need to categorize the images into the different categories that I've mentioned. So say, for example, the first one where we categorize the images as those being cars or not being cars. So this is one of the major activities, I would say, as a first step in building the deep learning model. As a next step, again, there are various layers, in terms of data cleansing and all of that. But to understand, the next important activity is where, the deep learning model comes into picture. And so the deep learning model basically helps in right classification of the damage, whether, as you see on the right hand side, it's a dent or a scratch, and where the damage is. And like we said, we've used the convolution neural networks here, which is a deep learning model typically used for image processing. And for our problem statement, basically we've used a CNN-based architecture which typically consists of around 10 layers. Now, as you see here on the diagram, the image is being processed via various layers. What you see, a convolution plus ReLU, then a pooling, a convolutional plus ReLU, all of these is layers which the image gets processed under, right? And each layer basically processes the image further. So like you see, the convolution layer basically puts this input image, that is the damaged vehicle, through a set of convolution filters, and each of which will activate certain features about the damaged vehicle image, right? It then tries to create a kind of minimum parameters to learn about the input image. And as a next step, attached with that is ReLU. Now, ReLU is basically a rectified linear unit, and it's a rectifier function that is basically used, to increase the non-linearity in our images. Because typically images are non-linear in nature, right? Like say, for example, the colors, the borders, all of these are very non-linear features with respect to an image. Moving on, the next layer is, as you see, the pooling layer, which is very similar to the convolutional layer, except that it connects nodes to the local regions of the input. Like you can see here, there are nodes which get connected to the regions of the input, and it reduces basically the number of parameters that the system needs to learn, right? And then finally, you also have at the end a fully connected layer, which is typically how a deep learning model would generally have a fully connected layer at the last of the model, which basically takes in all the inputs are connected, from the previous layer, all the outputs from the previous layer are connected to the input of this layer. And then you have a softmax function, which is basically used to do a probability distribution over the predicted output classes. So this, in a nutshell, is where the deep learning model comes into action and then classifies the image as it being what type of damage and the severity of the damage. Okay. Now, for our exercise, while we are still working, so this, like I said, is a white paper that we've created, and we are still working on completing the solution for it. We've developed this model in process where we are trying to create it using TensorFlow, and which is again, a library, which is a deep learning based library that runs, and we've used Python as our scripting language. So this basically explains the deep learning model. Now, moving on, the cost estimator is basically another solution, or rather another part of the solution. Once we have the vehicle damage determined, and that can then be fed into this cost estimator solution, which is basically a kind of a repository that maintains an inventory of all the parts based on the make model of the car, and then gives you a cost of replacement for the same. So there are various solutions which are available in the market through which one can create these kind of cost estimator solutions that can directly be plugged in from the output of the deep learning model. Uh, Moving on, so what we see as a benefits to this is, like we said earlier, uh, when we have a human involvement, there is definitely a kind of a bias. So here we're trying to do it via an automated model. So there's a fair assessment, and it helps in reducing the claims time processing because we are now doing an automated solution. So instead of a manual approach, we're reducing it from a 2 to 3 weeks to around 1 to 2 hours. And of course, it helps in saving the cost because we're doing away with the manual intervention. So again, just to add another point to this, we cannot completely do away with a manual intervention because in this solution, it is just trying to address the external damages which are done to a vehicle. If we still need to address the internal damages, this is currently not a part of scope of the solution. Different approaches can be leveraged, but then that's currently not in scope. So hence, as part of this current solution, we see that it reduces especially the part where you need to inspect the vehicle external, for any external damages, right? And besides, it also helps in providing a better customer experience. We saw the whole process where a customer could go ahead, uploads an image of the damaged vehicle, and he can then real time get a fair assessment of the damage replacement. Okay, so I'll leave you behind with a short video, um, which will explain you the current scenario. So just to conclude, uh, we've tried to propose a solution for calculation of a damage which is done to a vehicle, based on which that can go and be fed in onto a cost estimator. Now, the various solutions which are available, like Auditex, which helps in determining the cost estimation for the damage replacement, uh, and then it also helps insurers to help, providing the dispersal of the insurance money with respect to any damages. And it helps in acting as a key differentiator by providing an automated solution for selecting an insurance provider by the customer. So leave you behind with a short video. And this is pretty much what I wanted to cover as part of today's discussion about the automated solution of the vehicle damage detection.
Yeah. Thanks, Vijay, for taking us through this. We have a query from Thomas Wessling, who says, what are the requirements for the user to make a proper picture of the damage? I can imagine if the photo has been taken too closely, the AI could only recognize the damage but not the car. So this was when we were discussing slide number 11, the deep learning model.
Right. Okay. Right. So the requirements for taking the proper picture of the vehicle would be, yes. It has to be a proper picture of the damage. We typically would recommend, having multiple views of the same photograph of the damage. It could be a side view. It could also be, a view that is taken from different directions, I would say, to be able to and then, yeah, the image, like we saw in one of the slides also, is focused more on the damaged part of the vehicle also. So it's able to correctly identify, especially the severity of the damage, I would say. So yes, the input would be different photos that are taken of the damaged portions um, of the vehicle.
Okay. He also mentions that you could add an option to upload a picture of the license plate that could link to the license holder and potentially identify the car as well.
Yes, that's a good solution proposal, Thomas, because like I said, the current solution, the way we've envisioned this is one, it would be a mobile app-based solution where a user who's already registered with the insurance company would be authenticated via the app itself. So all his details would be automatically retrieved by the system. So once he takes, a picture, I think a good additional step would be you take a picture of the license plate so that it's able to read the details of the car and the vehicle owner, and then match it against the person's details which are taken in from the authenticated system, so that there is no claim coming from any other vehicle, which is not the current user's car. So that definitely could be a good addition to the solution in terms of doing that additional authentication layer, I would say.
Right. So
Thanks for
we
that.
have one more query from Prashant who says if the user uploads picture which is edited via Photoshop, will this AI train to identify or recognize the faulty part of the vehicle?
So I would say in the current scope of the project, identifying whether it is uh, photoshopped or not is something that we haven't addressed as part of the solution. But then yes, we can definitely look at it. I'm not sure how feasible that would be, but in the current scope, no, it doesn't address that part.
Okay. So attendees, please feel free to let us know your queries to the chat or the Q&A sections. Meanwhile, I personally do have some queries regarding the topic as well. So we discussed about how we could implement this machine learning to access this vehicle damage and how it could automate. So what are the challenges you see in implementing this solution?
All right. So every machine learning model is, of course, not 100% accurate. One of the major challenges is, the classification of the model, or rather the classification of the damage, whether it's putting it in the right severity and type. That would be one challenge. Maintaining a huge inventory of the cost estimator solution is also quite, I would say, a bigger part of the challenge, given that, like I said, the solution doesn't take care of the internal damages. It only inspects the external damages. I think I would say one of the other challenge would be to be able to reach that level of accuracy of the model, so as to give the right classification and maintaining the inventory of the parts for the cost estimation solution.
Okay. So which are the areas do you think which we need to concentrate, to access this, or how to make this more better solution?
So I would say fine tuning the model is basically a kind of an approach which can be incrementally done. There are various ways to tune the model. So, like we said, in this particular case, we've used a classification algorithm, a deep learning model, by increasing the uh, the number of images being fed to the data set. That becomes a very important factor, because the more the model is able to learn, the better is its performance. Giving a right mix of training the data set, testing it, validating it. All these become important parameters. And then, identifying the right parameters that influence the solution. All these play an important factor. That's again an important part of training the deep learning model. So I think that's where the focus is on.
Okay. So we have one query from Michelle who says, in the case of severe damages, such as could be seen in one of the picture, would the AI recommend an in-person inspection? I'm thinking about internal damages you just talked about, which can only be seen through a more through inspection.
Right. So probably the case where the model, so the way we've envisioned this is in terms of getting a percentage threshold of where the damage is being classified into an appropriate category. Now, where it is not able to do so because of the input image that is being put in, where it's not able to rightly classify based on that threshold, a way could be, to transfer this solution to the by dropping in or notifying the representative via email. So I would say based on the probability of classification, we could have that uh, move to have this manually inspected. Because then that would also involve, but I wouldn't classify that as necessarily an internal damage, because based on whatever damage is done to a vehicle immaterial, or whether whichever type or severity, there could be a probability that there is internal damage. So I would say based on the probability where it is not able to appropriately classify, it could be one use case to be able to hand it over to a manual agent.
Right. So participants, in case of any more queries, please let us know through the chat and Q&A sections. So we don't have any more open questions for now. So in case you have any queries, please feel free to reach Vijay anytime through email. And thanks a lot, Vijay, for taking us through this particular webinar and letting us knowing more about the topic. Thanks for your time.
Thank you. Thanks, everybody.
Okay, we have one question coming from Arthur. He says, please wait. So Michelle says, what's the current accuracy of the model?
Okay, so like I said, we are currently in the process of building. Like we spoke, it goes through four processes. One of it is where we identify the car, um, whether the image in the input image contains a car or not, and then the damage, whether the car is damaged or not, and then the severity. So we're still currently in the second phase of it. So we've used a pre-trained model, which is called VGG16, which is basically the concept of transfer learning. And we've observed an accuracy of around 96%. Again, based on what we have fed with respect to the current data set. The next layer, parts of it, which is the subsequent parts, identifying the damage and severity, is something we still have to get back on the results.
Okay, so we have one more query from Arthur who says, does it work well when the pictures taken are not normalized? For instance, a photo that is a zoom of one of the part of the vehicle.
Deepika, if you could repeat that question again for me, please.
Sure,
Sorry, I didn't
uh,
hear that.
no problem. So Arthur says, does it work well when the picture taken are not normalized? For instance, a photo that is zoom of one of the part of the vehicle.
So if the image, the input image that is taken is quite zoomed in onto the damaged part and not probably the surrounding areas of the car, I believe that's what your question is. Then that is something that we need to test additionally. Like I said, we are still in the phase 2 and 3 where we are still trying to train it. But definitely, I'll get back to you on the results in case we are able to observe the results with respect to the zoomed part of the damage.
Arthur, I hope that answers your query. So Arthur says we have a similar project right now that we will start probably in September. And he says, yes, thanks a lot for the answer.
Sure, Arthur, do reach out to us in case, because we are currently working on getting the solution available as an API. The complete machine learning model would be available as an API. And once we have that, we could access it from a mobile app or a web application. So that's the plan or the roadmap ahead. You can definitely, get back to us on the finer details with respect to the overall architecture.
Yeah, perfect. So he says, please communicate with me when something is ready. And thanks a lot.
Sure.
So any more queries, anyone? Please do let us know. Okay, I guess that's it from all of us. Thanks again, Vijay, for taking us through this.
Thank you. Thanks, everybody.
Yeah,
Have a good day.
thank you. Bye bye.
Bye bye.